Good afternoon, students. Today we'll talk about the definite integrals. Today we'll talk about definite integrals. Let us see what we can understand about the definite integrals. Now we have this curve. We have this curve. So now we'll say about this is a curve, that is we have x dash, y dash, it is y and x. Now let us try to make the value. Let's try to solve this. Okay, so this curve is something looks like as okay. So now y is equal to fx. Okay, so we can say we'll say that this is a lighter portion and it is a dark shaded portion here. Now we have the curve y is equal to fx. Okay, that is the area. If I say this area represented by this is bounded by the curve, that is y is equal to fx. So this represents the area. Now if we say here that is ax is a function of x, so we will say ax is the area of that function, so we can represent it as, that is a to x, representing this region. We'll write this, okay, where fx, we say that where x is greater than 0 and x belongs to closed interval, that is a and b. Okay, so this is the area. A is the area, we can say area function, and we can write this because this area represented by this portion. Now from this we have two theorems. First theorem says if f is a continuous function, if f is a continuous function, okay, in a closed interval, from a to b, so we will say that a dash x is equal to fx. Okay, a dash x is equal to fx. Okay, so that is what they have given, x to a. Now second theorem says if f is a continuous function in a closed interval f, a and b, and f is an antiderivative of f, then we'll say that fx dx a to b, now I'm taking the whole area, can be represented as fx b to a, and we can write as fx, that is, if I write this, we'll get fb minus fa. Okay, so if f is a continuous function in a closed interval, then and f is an antiderivative of f, so this term looks like this: integration of fx a to b with respect to dx, we get this. Okay, so these are the two theorems based on this definite integrals. Now we'll apply these two theorems in numericals so that we can easily understand about this definite integral. Okay. Now we'll try to solve numericals on definite integrals. Let us see one by one what they have given. I hope it's clear to you. So now we'll move to the next topic. Now we'll try to solve numericals on this concept now. So we have few numericals here. We'll solve them one by one. So we have first numerical, that is -1 to 1 x plus 1 dx. Okay, and okay, so now let us see how we can solve this kind of numericals. Now first we will integrate. So I got x square by 2 plus x. Then now we will apply the formula, that is that we will apply the limits, that is 1 square upon 2 plus 1 minus, and we have minus 1 square upon 2, then we'll have here plus 1, so it will be minus 1. So now let us see how we will find the answer here. So half plus 1 is 3 by 2 minus, here I got half minus 1. So okay, so half minus 1 will be minus half. So we will write this. So I finally found my answer, 3 by 2 plus half. So 4 upon 2, I got 2. Okay, like this we try to solve the numerical on definite integral. Now let us try to solve the another numerical we have. Now the next numerical is given here is, that is we have 1 upon x dx. Now 2, 3. Next let us see how we can solve this in a very easy way. First we'll integrate it. 1 by x is equal to log x plus c. I will put the value here 3, 2. So we will got log 3 minus log 2 plus c. So now we'll have log 3 upon 2 plus c. Okay, so that is how we able to solve these integrals, that is to find that's the question we have, that is to evaluate the definite integral. Now let us see the next numerical we have. The next we have, that is 1, 2, 4x cube minus 5x square plus 6x plus 9 plus 6x plus 9. Okay, so now let us see how we can solve. First we need to integrate it. So we got 12x 4, no, we'll have x4 upon 4 minus 5x cube by 3 plus 6x square by 2 plus 9x. Now we'll put the value here. Okay, first let us solve how much we can solve here. So I got x4 minus 5x cube by 3 plus 3x square plus 9x. Now let us put the limit. So I got here 2 to the power 4 minus 5 into 2 to the power by cube by 3 plus 3 into 2 square plus 9 into 2. Okay, now minus, now we will put the value minus, we have 1 to the power 4 minus 5 into 1 to the power cube by 3 plus 3 into 1 to the power square plus 9 into 1. We'll open the bracket later and we'll multiply with the negative sign outside of it. Now I got this value 16 minus 20 upon 3 plus 12 plus 18. I need to sort it out this. minus, then I got 1 minus 5 upon 3 plus 3 plus 9. Okay, so now my next step will be, we need to take the LCM here, and I got the value. Let us solve it here now. So now what I will got here, that is 48 minus 20 plus 36 plus 54 upon 3, and here I got, if I take the LCM, 3 minus 5 plus 9 plus 27 upon 3. We will open the bracket later. Now let us try to solve this. So I got 48 plus, if I add these, so I'll got 38 minus 20 upon 3 minus, here I got 9 minus 5 upon 3. So I got here 118, okay, upon 3 minus 34 upon 3. Okay, so I got what? Now we need to subtract it. 484 by 3. If I divide this, I got 28. Okay, so that is my answer. So like this, we can evaluate the definite integrals. Now let us try to solve more definite integrals. We have just solved only 3. So now we'll try to solve in a simple way. First we need to integrate them, and we need to apply the limit. Now let us try to solve the fourth numerical. Okay, so we have fourth numerical here, that is, let us see what it is given here. The fourth numerical we have sin 2x, and the limit I have power 4 0. Okay, now let us try to solve. Sin 2x will be minus cos 2x by 2. So now we'll put the limit here, and we'll try to find the answer here, that is minus cos 2 into pi by 4 upon 2 minus cos 0 upon 2. So if I try to solve, we'll get pi by 2. Now cos 90 is 0. We all know cos 90 is 0 because cos 0 is 1. So now 0 upon 2 minus cos 0 is 1. And we have negative sign outside. No? So now what I got here is 0 minus half, usually plus half. Okay. So like this we can solve, or we can say evaluate integral. Now let us try to solve the fifth numerical. We have just tried to solve only 4. Now let us move to fifth one. Now they are saying 0 pi by 2 cos 2x dx. Now what will happen? Now let us try to solve this. First we'll integrate. We got sin 2x by 2. Here I got value pi by 2 0. So now we'll put the value sin 2 into pi by 2 upon 2 minus sin 0 upon 2. Okay, so now let us try to solve. We have sin 180. So sin 180 is minus 1 upon 2 minus 0. Here also I got my answer, that is half, because we all know that sin 0 is 0. Okay, so now try to solve the next numerical, next definite integral, e raised power dx, that is 1 2. Now we'll easily able to solve. We know that e raised power x integration will be e raised power x, and now to 1. So now we'll try to sort it out. This will be e raised power 2 minus e raised power 1. Okay, plus c. So that is how we are able to solve this. Now let us try to solve the seventh. We have applied these two. Now we have 7, that is tan x dx, and we have 0 pi by 4. Okay, so now we'll apply to solve this. Okay, now we'll try to solve tan x first. We'll put tan x is equal to sin x upon cos x, then we'll have, okay, so now 0 pi by 4. What we can do, put cos x is equal to t, so that minus sin x dx is equal to dt. So I got here minus outside 0 pi by 4 sin x, so it will be dt upon t. So I got minus log t plus c. Log t plus c. Now what is the value of t here? Log t now I am taking, that is log cos x plus c. Okay, so now we have this, or now we have integration now of 1 upon t here, or we can say this value will be, now we can say minus log cos x plus c. I can write log sec x plus c. Now we'll apply the value here, that is pi by 4 0. Okay, now sec 45, we know the sec is the reciprocal of cos. Now cos 45 is 1 upon root 2, so it will be root 2. So we'll have log sec root log 45 will be log root 2 minus sec 0 cos 0 will be log 1. So I can write log root 2 upon 1 plus c. Okay, so that is how we can easily find the definite integral. Okay, so that is how we apply. Let us try to solve more questions on this. Let us see how we can easily solve. So now we'll try to solve the question here we have in my hand, that is now we need to find cosec x. Okay, so the value they have given is, that is the value now I have, so we'll put here, that is pi by 6 to pi by 4, we have cosec x. We have cosec x dx. Okay, so now what we can do here, write cosec x is equal to 1 upon sin x dx. Okay, so now we can say that integration of cosec x will be 1 upon sin x, that is now we need to integrate it. So now we'll see the answer will be log sin x plus c. So now we can put the value here. Okay, so now we'll try to find the integration of cos x. We have the formula, that is log cosec x minus cot x. So directly we will apply that formula here, so that we are able to find the value. So now what will happen, log cosec pi by 4 minus cot pi by 4. Okay, minus here log cosec pi by 6 minus cot pi by 6. Okay, so now let us try to solve cosec 45 is the reverse of sin 45 1 upon root 2. So it will be we'll have root 2 minus cot 45 will be 1 minus log, we know cosec 30 is the reversal of sin 30. So now we'll see sin 30 is half, so it will be 2 minus, we'll take cot 30, tan 30 is 1 upon root 3, so it will be root 3. So now like this we can put the value here, root 2 minus 1 upon 2 minus root 3 plus c. Okay, so likewise we can find, that is we can evaluate definite integral. Now let us try to solve more. We know the formula of that, so we can easily apply on it. So now we'll got here, that is 1 0, that's my 8th question. Now I am solving it 9th, that is dx 1 minus x square under root. Okay, so now we can say, let us try to solve this question now. Now we'll try to solve the integration of this. We'll got sine inverse x, we have plus c. Now we'll put the value sine inverse 1 minus sine inverse 0. Okay, so we all know 1 we can write here, so it will get 5 by 2 minus sine 0. So sine 0 is 0, so I got my value 5 by 2. So likewise we can solve to evaluate the definite integrals. Let us try to solve more. Now I have 10th numerical. Okay, let us see what the 10th numerical says. Now the 10th numerical is about dx upon 1 plus x square, that is dx upon 1 plus x square 0 1. Okay, so now we'll try to solve the numerical in a very easy way. That is, now let us see how we can solve. The integration of this will be tan inverse x. Okay, so now we'll put the value 1 0, that is tan inverse 1 minus tan inverse 0. So now tan inverse 1 pi by 4, so I'll got pi by 4 minus, so we have tan 0, that is, so it will be 0, so I'll got pi by 4. Okay, so this is how we able to evaluate the definite integrals. Now let us try to solve more. Now a very simple way. Now let us solve the one more numerical we have. We have just solved 10 numericals. Now let us try to solve more numericals. That is, now I have in the 11th we have 3 2, we have dx x square minus 1. So now here we'll apply the formula 1 by 2 log x minus 1, 1 by 2 log x minus 1, x plus 1 plus c. Okay, that is x square minus a square. So we'll have a by 2 log x minus a upon x plus a plus c. Now here we'll apply the value. Okay, so I got what? Log 3 minus 1 upon 3 plus 1 minus log 3, we have 2 here, so 2 minus 1 upon 2 plus 1. Okay, so now we're able to solve this. I got log 2 upon 4 and minus log 1 upon 3. 2. Okay, plus c we have. Now let us see. I got my answer here. That is log half minus log 3. log half, so I can get half upon 1 upon 3 here plus c. Okay, so now what I can do here, well, answer will be log 1 upon 2 into, so it will be 3 upon 2 plus c. Okay, so that is how we able to evaluate the definite integrals. Now let us try to solve more. Now the next we have, next question in my hand, that is 12th question we have. Now the question is cos square x. Now I am solving here. Okay, so the question is cos square x dx 0 pi by 2. Okay, so this question we have. So now we'll try to sort it out, that what to write in our simple way. Cos square x dx, we all know the identity of the cos x. Cos 2x is equal to 2 cos square x minus 1. So I can take there 1 plus cos 2x by 2. So I can write cos square x value here. So it will be, cos square x value will be 1 plus cos 2x by 2, and we'll try to integrate. So I got here x plus sine 2x by 2. We have half outside, and I got a value of this much. So now we'll try to put a value. So I got this half pi by 2 plus, if I write pi by 2, so I got sine pi upon 2 minus 0 minus sine 0 by 2. Okay, so now we all know sine 0 is 0, so it will all be 0. Now I have this one, pi by 2 minus 1, so I got this. My answer, I can multiply inside pi 4 minus half will be my answer plus c. Okay, so that is how we easily evaluate the value. Okay, so now we'll try to solve more. Okay, now we'll solve more numericals on definite integrals. I hope now it is clear to you in a very easy way. They have, we have now learned how to evaluate definite integrals. Okay, now let us try more. What else? Now next they have given is 2 3 x dx upon x square plus 1. Okay, now this is a question how we can solve in a very simple way. Put x square plus 1 is equal to t. So I got 2x dx is equal to dt. So we'll put a value here. dt is equal to half will be outside, and we have t. So we know the integration of this log t. Okay, plus c. Now what is the t here? We have to put it again, log x square plus 1. So I got this. Now I can easily put these limits in such questions. Now see what they have given is half log 3 square 9 plus 1 minus log 4 plus 1. So it will be 5 plus. So I got half log now we can see that is log x square plus 1 whole cube. So whole limit I have 3 by 2. Now I can put the value 10 upon 5. Okay, plus c. So I found the value log 2 plus c. Okay. So that is how we able to solve the numerical. Now we'll try to solve the next. Try to solve to evaluate next definite integral. Okay, so we have that is next question in my hand. So now let us try to solve this. They have given 2x plus 3 5x square plus 1 dx 0 1. Okay, this question in my hand, and let us see how we can solve this kind of numerical. Okay, so now let us see how we can solve. Now let us try to solve this numerical. What we can do here, first multiply with 5 and divide by 5. So I got 10x plus 15 upon 5x square plus 1 dx. So now what we can do here is separate it, 5x square plus 1 dx plus 15 upon 5 dx 5x square plus 1. Okay, so now how we can solve, let us see. Put here x, this one 5x square plus 1 is equal to t, so that 10x dx is equal to dt. So I will have 1 by 5 okay, dt upon t here. So dt upon t plus here we will have reduce it 3. So I'm taking 5 common outside. So we'll got x square plus 1 upon root 5 whole square. So here I got 1 upon 5 log t. Okay, so we have 1 upon 5 log t plus here I will apply the formula for dx upon x square plus a square, that is it will be tan inverse x upon a plus c. Okay, here I got 1 upon 5 log, what is t I have taken, 5x square plus 1 plus 3 upon 5 tan inverse x upon 1 upon root 5 plus c. Now I can put the value which I have to put here, that is 1 0. Okay, so now I have to take care of these limits I need to put. So I got here 1 upon 5 log 5 plus 1 6 upon 1 plus 3 upon 5. If I put a value 1, so I will have tan inverse root 5. And if I put 0, it will be 0. So I got value this. Okay, so my final answer will be 1 upon 5 log 6 plus 3 upon 5 tan inverse root 5 plus c. Okay, so that is how we able to evaluate the definite integrals. Now we'll solve the next numerical I have. Next numerical on definite integral. Now a simple way they have given, that is x e raised power x square dx. Now they have given this is the question of definite integral. Definite integral, the value is, the limit is 1 0. Okay, so now how can I do it? Just put x square is equal to t. So 2x dx is equal to dt. So now 2x dx is equal to dt, x dx will be dt upon 2. So I can put here like this, e raised power t dt. Now we know the integration of this, et plus c. So now we have half e raised power 1 minus e raised power 0 plus c. We know any variable, any number having the power 0, it will be 1. So I got half e plus c. Okay. So that is how we solve. Now let us try to find another integral, another value of definite integrals here. Now I have the question, that is 5x square. Let us remove this first. So now I have the question here, that is 5x square upon x square plus 4x plus 3. We have 1, 2. Now let us try to solve such kind of numerical, how we can do it. Now what will happen, we can take this as divide 5x square by this. So I will get 5 sorry, minus, you will got 20x plus 15 upon x square plus 4x plus 3. Okay, so now we have this with respect to dx. Now we can separate them. 5 dx 1 2 minus this 20x plus 15 upon x square plus 4x plus 3 dx. Now we need to separate them, integrate them separately. Now I will got this one, 5x, we have 2 1 minus. Now what we can do is just this is the value which we have. This is, let us take, this is I1 and this is I. So we'll take I1 is equal to 5x minus I. Okay, so now we'll solve this. How we'll solve? We can do like this. 15 is equal to a d by dx of x square plus 4x plus 3 plus b. Okay, now here what they have given is 20x plus 15 is equal to a. Here we have 2x plus 4 plus b. Now if I compare what I got here, 2a is equal to 20 and 4a plus b is equal to 15. So we can say here a is 10, so putting the value of a 10, 40 plus b is equal to 15, so b will be minus 25. Okay, so now putting the value in this, I got a, I have 10, so I'll take it outside, dx upon, now I'll take the value x square plus 4x plus 3. Okay, a divided x plus we have b minus 25. Now I have got this value. Okay, x square plus 4x plus 3. Okay, now here we'll put the value, this one, 20x plus 15. Okay, so now I have taken the 10 outside, so we can write this. Okay, 2x plus 4, because we have taken here a, 2x upon 4 upon this plus b. Now we will try to solve. How? Put x square plus 4x plus 3 is equal to t. So that 2x plus 4 dx is equal to dt. So I got dt upon t, 10. So, and here minus 25, what I can do? Dx upon, now we can take solve by completing the square, x plus 2 whole square plus 3. So what will happen? It will have minus 1 square. Okay, so because we have what we have done, plus 4, so x plus 2 whole square minus 4. No, 3 minus 4 minus 1, so it will have here minus 1. Okay, so now we know 10 log t, that is x square plus 4x plus 3 minus 25, and this will be 1 upon 2 log x minus a upon x plus a plus c. So that is how I got my answer here. So now what we can do here, we can easily put the value here for the definite integral. We'll take here. Okay, that's for the 2 1 we have. And plus we have this value also, no? So now we'll put here, that is, if I put the value 5x, so 10 minus 1, 9. 9 minus all this. Now I'll put here, so I'll got 9 minus to the 4 plus 8, 12 plus 15 minus 1 plus 4, 5 plus 3, 8 upon 8 minus 25 upon 2. Here I'll put a log 2 plus 2, 4 minus 1, 3 upon 1 plus 2, 3 plus 1, 4. So that's my answer. Okay. So that is how we can easily evaluate definite integrals. Now we'll try to solve another numerical that is based on definite integral. Now let us see how we can try to solve. Now we have another question here, that is, let us see what the question is. 2 sec square x plus x cube plus 2 dx. Okay, they have given 0 to pi by 4. Okay, so now let us try to solve this. We know the integration of sec square x, that is 2 tan x pi by 4, 0 plus x4 by 4 pi by 4, 0 and 2x pi by 4, 0. So what will be its value? 10 pi by 4, 1, 10 0 is 1, so we have 2 plus, here if I put the value of pi by 4, I got pi by 4. Okay, pi by 4 whole 4 upon 4 minus 0 by 0 plus you have 2 into pi by 4. Now what I got here, 2 plus pi whole square, for multiply this 56 into 4, 256 into 4, I'll got 1024 plus pi by 12. Okay, so that is how we able to evaluate the definite integral. Now we'll try to solve another numerical based on that is to evaluate definite integral. We have sine square x by 2 minus cos square x by 2. So I have 0 pi. Okay, so now let us see how to solve it out. Very easy. What we can do here is just take minus sign common. Cos square x by 2 minus sine square x by 2. 0 pi. Pi, we all know the formula of cos 2x. So cos 2x, so we'll have here cos x Now let us try to integrate it. So I got sin x plus c. Okay, so now sin 180 we know 0, sin 0, so it will be 0. Because we know the value of sin 180 is 0. So likewise, we are able to evaluate definite integrals. Now we'll try to find the value of another to evaluate another definite integral. Now let us see 6x plus 3, they have given x square plus 4 dx, okay, 0 to 2. So now let us see, we have already solved 18th question today. This is my 19th question, okay. So let us see how we can solve them very easily. What we can do, take 3 common outside. So I got 2x plus 1 upon x square plus 4 with respect to dx, okay. So now next thing is we can separate them out. So I can write 2x upon x square plus 4 dx plus dx upon x square plus 4 0 to 2. Okay, so now we can easily solve. We know taking x square plus 4 is equal to t. This is I1, this is I2. Now we'll solve them separately here. So now put I1, will solve first I1. So I got 2x upon x square plus 4, 0 to 2. Put x square plus 4 is equal to t. Now what I will got, 2x dx is equal to dt. Dx is equal to dt. X dx is equal to t upon 2. So I will got here 1 upon 2. See, first we'll solve this so that we can easily put the value later on. X dx is dt upon t. So I got log t plus c. So I got here, I can put a value here. That is, what is t here? We have x square plus 4. So I can put directly here 3 into 1 upon 2 log x square plus 4 plus x square plus a square, will directly put the value here, that is 1 upon 2 tan inverse x upon a plus c. Here we will put the value, okay. Here also I will put the value. So 3 upon 2 log x square, 2 to the 4 plus 4, 8 upon 4 plus half, if I put 2 by 2, 1, tan inverse 1, 0, tan 0 will be 0, so we'll leave it apart, plus c. So I got my value 3 by 2 log 2 tan inverse 1 tan pi by 4, so it will be plus pi upon 8 plus c. So that is how we able to solve the definite integral. I have just solved this one here, put the value here, plus directly I have solved this by putting the formula here. Okay, so now let us try to solve next numerical we have to evaluate the definite integral. Okay, so now let us try to find how we can easily solve, now the question in my hand, we have for the definite integral, that is xex plus sine pi x upon 4 0 1. Okay, so now let us try to solve this. How we can solve? We need to separate them out so that I can write like this: dx 0 1 plus 0 1 sine pi x upon 4 dx. Okay, so now what is there? Here we can apply integration by parts. So what I will get here? First function, second function. First function is x, second function is ex. So minus, then we will do a differentiation of first function, that will be x, that is 1, and integration of second ex dx. Now plus, we know the integration of sin x will be minus cos x. So minus cos x upon pi by 4 we have. Now we can put the value here. So now what we can do here, we know x ex minus ex. Okay, so I got 1 0. So now minus we can take outside. So now if I put the value here, x is 1, so cos pi by 4 upon pi by 4 minus, now put the value here. Okay, just wait. Now we'll see if I got here cos 0 upon pi by 4. So I am just implementing the values. So now I can see here e raised power 1 minus e raised power 1 minus 0 minus e raised power 0 will be okay, wait, 0 will be 1. So now I got this. So cos 45 1 by root 2. So 1 upon root 2. So if I take, that will be 4 pi upon 4 pi. Okay, 4 upon pi. No. It will take like this, 1 upon root 2 into 4 upon pi. Okay, and we know cos 0 is 1. So I will got 1 upon pi by 4. Okay, so now I got this. So minus 1 minus 4 upon pi into root 2 plus 1 upon pi by 4 plus c. I can put it here. Okay, so that is how we are able to evaluate definite integrals. If you have any doubt, you can ask, comment, and share my channel. If you like my channel, you can also like. Okay, so that's for today.